So here we have what are called conic sections. This one is a parabola. When one of the variables is squared and the other one is not, that's going to be a parabola. When both variables are squared like this, then it could be an ellipse. If they're being added together, like this has an x squared plus a y squared, then it would be some type of an ellipse. If they were subtracted, x squared minus y squared, that's going to be a hyperbola. So first, for this parabola, well, if you have y equals x squared, that's a parabola that looks like this. It's opening up. Instead of having x squared, this one has the y being squared. So that means instead of going up or down, it's going to go to the left or to the right. Since the number in front is positive, it's going to the right. Now, the other thing we need to know is, if it's going to the right, then where is the vertex? And this one, luckily, is in vertex form. So, you take what's in the parentheses, use the opposite of this number, and that will tell you the y value. So the y value is a 5. And then if you substituted that y was equal to a 5, this would become a 0, so it would cancel out this, including the 2, and it would say x equals a negative 8. So that's going to be the vertex. So x is negative 8, y is 5, and it's going to the right. Now, in order to finish this part, label the graph carefully, I need to also provide where is this point, where is this point, and where is this point. So these 2 points are y-intercepts, and that is where x is equal to 0. So just go to the equation, put x equals 0, and then what we could do is add 8 to both sides to move this over to the other side. And then in the next step, what I can do is get rid of this 2 by dividing both sides by 2. So over here, 8 divided by 2 is 4. And then, in order to get rid of the square, take the square root of both sides. For the number on the left-hand side, make sure you put plus or minus the square root. So we get both answers, this one and this one. So plus and minus 2. And then the last thing to do is move the 5 over. So add 5 to both sides. And there are those 2 y values. So there is 5 plus 2 is 7. And then 5 minus 2 is 3. Oh, so actually this thing is much skinnier than I thought. So it goes through right here at 3. Well then, looks like I need a do-over on my graph. Good thing I've got the eraser right here. So, it's skinnier, it's like this. Alright, now I need to find this point right here where it hits the x-axis, and then that's going to be where y equals 0. So simply go to the equation, substitute y as a 0, we would have x is equal to, let's see, so this would be 2, and then 0 minus 5 gets squared minus 8. So this is going to be 25. Once you square it, it becomes a positive 25. Times 2 is 50. So we have x is 50 minus 8 is 42. So it's labeled correctly, not drawn to scale, because of course 42 would be much farther to the right. It would be like over here in the middle of this problem. Okay, so that one's done. Then for this one. This is going to be an ellipse. And the general form general equation or general form for an ellipse would look like x minus something is squared plus y minus something is squared. It has to equal 1, and then this is over a squared, and this is over b squared. So that's the form that we need to get it in. And once we do that, then the center will be at h comma k, coming from this number and this number. To get it into this form, we need to complete the square. So take the x terms, x squared and a 6x, and then leave a space. Take the y terms, plus y squared minus 4y, and then leave a space. So all I've done is just make some space in the equation. In order to complete the square, what we do is take the b term, here a 6, cut it in half and square it. So it's going to be a 6 gets cut in half, and then you square that. So that would be a 9. So that means add 9 to both sides of the equation. Alright, now do the same thing with this one's b term. So take a -4, cut it in half, and square it. So -2 squared is a +4, so add 4 to both sides. Okay, now you group these 3 terms together, and it can be factored into a perfect square. And in fact, it's going to be x plus 3 is squared. And I know that whatever number was in the parentheses there, that's what goes here. And then plus, for the y part, it would be y minus 2 squared. And if you multiply this out, it sure enough will equal these 3 terms. And that -2 is that -2 right there. And then this is going to be, what's that, 14 and 4 is 18. So the general form has it equal to 1. So what I have to do is divide both sides by 18. So it's going to be x plus 3 is squared over 18 plus y minus 2 is squared divided by 18, and then it's equal to 1. Or actually, since these two numbers are the same, then this is going to be a circle. So with an ellipse, you would go to h, k, that would be the center, and then let's say that this number a is bigger than this number b. So you would take the square root of this, get the a, and then you would move over by a in each direction. And then you take the square root of this, get the number b, and then go up and down. I'm going up and down because this is the y information. I went left and right with the a because that's the x information. So you go up and down, and then you would have a nice sort of skinny ellipse. Well, with this one, both numbers are the same. So that means we've actually got a circle. So the center is going to be -3, +2. So -3 and then +2. And then if you take the square root of this number, it will tell you the radius of the circle. So let's see, the square root of 16 would be a 4, so square root of 18 is a little bit more. So I need to go out by 4 point something in each direction. So to draw this approximately to scale, this would be the circle like that, where the radius is the square root of 18.